Hello. The term statistics comes from the Neo-Latin statisticum collegium, council of state, and from the Italian statista, statesman, politician. In 1749, the word Statistik was coined in German to mean science of the state. In the 19th century, it was defined as the compilation and classification of data. The aim was to make known the extent, population, agricultural and industrial resources of a state. And so statistics emerged not as a scientific tool, but as a tool of governance dealing with the collection, organization, analysis, interpretation, and presentation of data. Their mathematization, namely modern statistics, dates from the late 19th and early 20th centuries. They were developed by eugenists such as Francis Galton, Karl Pearson, and Ronald Fisher. Not only were many of its main tools and therefore its language developed for eugenic purposes, but statistical thinking is still based on a eugenic perspective, that of significant difference, a concept developed within a framework in which human beings were considered to be intrinsically more or less valuable, some being undesirable, with all that this might imply. Difference from what? An average, a median, namely the midpoint of a set of data, etc. In the biological and human context in which this thinking was developed, these concepts have no reality. To quote Claude Bernard, all these biological characteristics of the phenomenon disappear in the average. Mathematics already excludes most facets of a phenomenon because few are quantifiable and deals with identical objects by eliminating individual characteristics. They discard everything that differentiates and retain only certain common properties. So what is the significance of a quantified difference in relation to a numerical standard that has no reality? None, except the meaning we want to give it, which depends on our preconceptions, our paradigms, and our goals. So there can be no objectivity in a statistical interpretation. It's important to understand that numbers in themselves have no meaning. They are abstract symbols of a merely logical language. We give them meaning by interpreting them from our point of view. Modern statistics came into being at a time when the successful mathematization of physics had reinforced a mistaken belief in the objectivity of mathematics, even though the discovery of various geometries had already shown that any application is merely a point of view. Eugenists set up the statistician as a figure of authority, a numerical arbiter who is by nature impartial, statistical analysis being simply an impartial calculation of numbers. This erroneous paradigm of objectivity conceals the real subjective aim of differentiating between races, social classes, genders, or simply individuals, with a view to improving man or even creating a superman according to highly subjective criteria. But this paradigm led to the belief that developing statistics would provide a scientific basis for Darwin's thesis that natural selection of traits appropriate for survival occurs gradually over generations. The aim was to find mathematical laws of evolution based on measurable empirical data. For Galton, the founder of the eugenics thesis and the originator of the term, based on his assumption that the Darwinian thesis was hereditary, it was a matter of finding the laws of heredity. His mathematical studies led him to conclude that these only concern deviations expressed in statistical units. As it is not possible to study changes over several human generations, a fundamental question in eugenics, Galton had the idea of studying the deviations in the weight of sweet pea seeds produced over several generations according to the weight of the parent seeds. Why sweet peas? Because there is self-fertilization and therefore a reduction in the complexity generated by two parents. In 1786, the mathematician Gauss had developed his famous law of errors between the measured value and the true value, according to which the probability of positive and negative errors is the same, so that the random error can be minimized by repeating the measurements a large number of times. The arithmetic mean of all the measurements is then taken as the true value of the quantity measured. This so-called normal distribution is represented as a bell shape. Galton admitted that he had been influenced by statisticians who had extrapolated from this a law concerning errors to deviations of human traits and behavior from a norm, namely from an average. Apart from implying a judgment on possible deviation, this is assuming that there is a norm and that the probability of deviations decreases the greater they are. Already in physics, we can experimentally see that it is untrue, that the probability of an error decreases the larger it is, which is what Gauss's law implies. In fact, we can see in many cases that the large errors are far more numerous than the normal law indicates. In fact, a series of errors obeying the normal law seems to be the exception rather than the rule. Furthermore, this law involves a number of approximations, and when these are examined, it is found that the law should hold only up to a moderate multiple of the standard error, namely the standard deviation, a measure of the distribution of the data in relation to the mean. So even theoretically, the law doesn't hold up too well. It was therefore under this influence that Galton concluded in his study of sweet peas that each group of parental seeds of the same weight produces a family of offsprings whose weights are distributed around a mean in a Gaussian fashion, and therefore that the offsprings of a large seed are closer to this mean, with the size of the seeds following a distribution of the same type. He called this process regression. But apart from the fact that the average has no reality, what data does the average refer to? There are ambiguities about his data. It is not clear what quantities he used to calculate the standard deviation. However, a plausible assumption which is consistent with his data implies that he greatly underestimated the real variability of the size and therefore the weight of the peas. Moreover, he admitted that his experiments contained imperfections and that he had balanced doubtful cases. Be that as it may, he extrapolated the conclusions to human traits, which he had measured over 2 generations. He concluded that there is a regression towards the mediocrity that is the average, namely that parents of great stature or intelligence have on average children of smaller stature and less intelligence, etc. Intelligence is a point on which eugenics focuses. It suggested a precise regression coefficient based on assumptions and approximations and fraught with judgment, which is still in use. This is also the case for the notion of deviation and correlation between the characteristics of offspring and parents. From all these notions, he developed a statistics by comparison, which compares the abilities of different races. Galton's notion of correlation was more fully mathematized by the mathematician Pearson, a disciple and admirer of Galton and Hitler, convinced of Western superiority and of the evils of sympathy towards degenerates in body and mind by suspending selection. He founded the world's first statistics department in 1911 at University College London, one of the colleges of the University of London. Thanks to the fortune bequeathed by Galton to the college, where the Eugenics Society, then called the Eugenics Education Society, of which he was president, had its headquarters. We owe to him many of today's statistical procedures. There are several correlation coefficients, one of which he developed. He is said to have found that the coefficient is the same for physical traits as well for intelligence traits, which led him to declare, "We inherit our parents' tempers, our parents' conscientiousness, shyness, and ability, even as we inherit their stature, forearm, and span." But what we see in his work is that numerous inferences are simply not warranted given the data that was reported. Its statistical analysis and scientific method leave much to be desired. At least that was the conclusion of a review by statisticians of his study. The problem of alien immigration into Great Britain, illustrated by an examination of Russian and Polish Jewish children, published in 1925 in the Annals of Eugenics, a journal he had founded. Pearson used his statistics to compare intelligence. At the beginning of the 20th century, the psychologist Alfred Binet had invented the IQ, certainly not for eugenic purposes, but to help children with serious cognitive problems. But there is no need for tests to identify them. This is an extremely simplistic, mechanistic vision that equates intelligence with quantifiable criteria. Criteria that even in this vision raise many questions. Not surprisingly, Pearson never found a correlation between intelligence and head size, or between children's intelligence and their parents' literacy level. Finding no correlation, he divided the category of children into 2, girls and boys. Finding none for girls, he convinced himself that for boys the correlation he thought he had found is most probably significant and therefore confirms the not definitely significant results from the girls. Now, not only is his determination of significance questionable, but it is certainly not the case that a significant result from one test and set of data can confirm the significance of a non-significant result from another test and a different set of data. So what is the significance of a statistical result? Once again, it is an abstract concept which reduces to numbers the fact that the result has meaning and is not simply due to chance, in which case no conclusion could be drawn from it. Suggested by Pearson, his theory was developed by Fisher, a member of the Cambridge Eugenics Society, who was appointed professor in the Department of Eugenics at UCL in 1933. It is on his theory of tests concerning the significance of a result that the current statistical vision is based. To quote psychologists David Bacon and Paul Mill, respectively, a great deal of mischief has been associated with its use. It is a potent but sterile intellectual rake who lives in his merry path a long train of ravished maidens but no viable scientific offspring. Fisher's research between 1935 and 40 was funded in particular by the Rockefeller Foundation. Between 1930 and 50, it was the main financier of economic and social research in the UK and a leading funder in France. The foundation gave direction to the post-war economy, particularly in the choice of statistics to be applied. This choice significantly affected the type of economics which expanded in universities and government-related institutions after World War II. Statistics continue to implement the eugenist vision. We continue to test the IQ of children as well as employees and job seekers, and to compare universities, schools, and levels of education between countries using a variety of data. In this way, everyone and every group is pitted against each other in a hierarchical vision based on the prospect of profits, which standardizes humanity to the format needed to perpetuate it. The means used to achieve this goal is itself a source of profit. Tests have become a major commercial activity and their sale has exploded. Equipped with statistics, we estimate the extent of this or that trait in populations, of violence, of the harmful effects of medical treatments and other technologies, and so on. Despite all the studies, the problems are getting worse and the number of victims of all kinds is soaring. In the next video, we will use examples to discuss the merits of statistical applications. To what extent are methods with some merit in the study of gases composed of an infinite number of similar particles still appropriate when applied to samples of a few hundred or at most a few thousand individuals, all essentially different from each other, with a complexity beyond quantification, especially when they are equipped with a certain degree of free will? Thank you.